Alright, hello everyone, this is Mr. Crozier, and I got some questions on the Canvas quizzes, so here we go. Question 20, it has an object here in the middle being pulled in 4 different directions, and you can put the unit circle measurements there and simply add up the vectors. And if you add up these vectors, you will have an A and a B, and the question's only finding the magnitude, so you'll be good with that. There's a shortcut for this, but this is one way to do it. 25 tells you that a person wants to go this way, but the current is going up. So therefore, if they want to go straight across, they're going to have to angle down, and that current pushes them up. So we have to find this angle. And if we put these measurements on here, we have -5 and 15. Can make this triangle. Use SOHCAHTOA because it is a right angle. And once we have that, the -19 goes right here, and what that means is this is the direction of the boat. And there's lots of different ways to talk about this direction. We could just say it's a -19. However, the way they want it here is the direction south with a 70.5 degree turn to the east. It's just a different way to write bearings. Number 10 is a dot product problem, and the work here for the dot product is 3 times -4 is -12, plus 5 times A gives you the dot product. So they give you the dot product, and they want you to work backwards to figure out what that A is. Drop a line and solve that equation. You'll have the answer. Questions here, 17 and 18. 17 and 18 on test 2 are about polar coordinates, and polar coordinates are simply magnitude and theta. So it's just a fancy way to say magnitude and theta. So with these components right here, A and B, we can find magnitude like this, right? And we can find components like this. Just be careful of what quadrant you're in, of course, when you're finding the angle here. But again, that's all they're asking for. These are the components. Find these, and you'll see them written with parentheses here. And the same deal down here on number 18. What are the rectangular coordinates? Well, all they want are components. What is the x change and the y change, or just what is the x, y values? And we're talking about this point, and that 3 is the magnitude, and this -6, or pi over 6, -30, right, is the theta. So you can just do, what would that be, 3 cosine of -pi over 6 and 3 sine -pi over 6. Just some vocabulary. Polar coordinates, components. 20 down here, we have this vector drawn here, -4, 6. I did a squared plus b squared to get the magnitude here, which is √52. And what we want to do is take this vector, that's this long vector of √52, and compress it down until it's only a magnitude 1. And we do that by multiplying by a scale factor. So 52 times something gives us 1. K is √52, whoops, over 1. So 1 √52 into this vector, and we just distribute this in there. So the answer is the components -4 root over 52 and 6 over √52. Basically all I've done is divide this down by the magnitude. Now they want only the y component, so they only want this component here. But you're going to have to simplify that radical. Question 22 and 23 are related, and it's about a plane going in this direction and the wind going in this direction. It's blowing from the west, so from the west to the east, and we have these two vectors. Simply add the vectors, vector A plus vector B, get the resulting vector, and on this one you want the speed, so you want the magnitude, right? After you add these two vectors, you're going to get an A and a B value as always. It's the exact same problem here. You just add the vectors and get your two components. But the problem is that these are in bearings, and we're going to use the unit circle. So what we need to do is take this same picture, but change the degrees to 0, 90, 180, and 270, and it's still a 30-degree turn from due south and a 60-degree turn down here, so it's still 30 and 60 there. So that makes that angle 250. So when I use it for the plane, sorry, 240, it's 240 here and 240 here and 0 and 0, and the result is A and B. So it's the same thing, however, you have to change it from the world of bearings to unit circle, and then you'll be able to do the work. Because whenever you have the cosine and sine, whoops, this one is sine right here. Whenever you have cosine and sine, you have to be in the world of the unit circle. Now, one last thing about this. Once you get this angle, you do this work right here, and you do inverse tangent of B over A. Once you do that work, you're going to be in the world of unit circle, and you're going to have to translate it back into the world of bearings. And so whatever this comes out to be on the unit circle, it's not going to be what your answer is, because they want a bearing here. So what you do is you take it and you draw it once, and you put these numbers in here so you know what kind of turn it is, and then you put these numbers back in here. And once you put those numbers back in there, you can, I'll give you a clue. What you're going to be doing is you're going to be going down from 270, down from here, or up from 180. Whatever you do, you're moving from there. All right, the last one says you swim at a speed of 4.2 across a river. However, the current's pushing you down. So obviously you're going to go faster. So it's going to take this 4.2 and move it faster down in this direction. Well, that's a right triangle. A squared plus B squared equals C squared. And you could just use Pythagorean theorem. This problem you could do 3 different ways. You could think of it as vectors. You could think of it as SOHCAHTOA, or you could just think of it as A squared B squared equals C squared, Pythagorean theorem. All 3 of them work here. Vectors work, SOHCAHTOA works, Pythagorean theorem works, because this is a right angle. And the direction of the current doesn't matter, because we're only talking about magnitude. So whether we're going down or up, we're just talking about that length. All right, I hope this helps on your quiz problems.